All right, so I think this is recording. Let's take a look here at problem number 2. We want to solve this radical equation. We have to make sure that when we do get our possible solution set that we check it for extraneous solutions. When we're solving these radical equations, we want to make sure that we have the radical by itself. This time for this problem, we really don't have to worry about that because whether you're looking at the left-hand side or the right-hand side, each have a radical and they're equal to each other. So it's going to be easy to get rid of these radicals by squaring them. If we square the left-hand side of this equation, to balance the equation, we're going to also square the right-hand side. So what that accomplishes, that cancels the radical. So on the left, we just have 4 minus x. And on the right, we have x divided by 3. All right. So to solve this equation, you might solve it like we did previously with the rational equations. It should be fresh in your mind. If we look at each one of these, we see that we do not have the same denominator. We want to have a denominator of 3. So for this first term, we'll multiply this by 3 over 3. And for this second term, we'll do the same thing because it's missing a factor of 3. All we're doing is multiplying by the number 1, so we're not changing the problem. And over this fraction already has a denominator of 3. So when you multiply fractions together, it's very easy. You just multiply the numerators together. 4 times 3 is 12. And you multiply the denominators together. 1 times 3 is 3. And then over here, we multiply the numerators, x times 3, and we more commonly write that as 3 times x. 1 times 3 is 3. So now that we have a common denominator, if we were to multiply every term in this equation by 3, these denominators would all cancel. We can clear the fraction. We can write this as 12 minus 3x is equal to x. And this is now going to be easy to solve. I'm going to add 3x to each side. And if I add it on the left-hand side, the negative 3x and positive 3x will cancel each other out. I'll put a 1 right here to visually help me. If I have 1x, I'm adding 3 more x's, then I have a total of 4 x's. If I divide each side by 4, I have a possible solution of x equals 3. Now I say possible solution because when we squared both sides of this equation, we could have introduced extra solutions, extraneous solutions. So we're going to have to check this in the original equation to make sure it satisfies it. So on the left-hand side, we have the square root of 4 minus x. But we believe x to be 3, so we have 4 minus 3. Well, that's 1, and the square root of 1 is 1. Now, the question is, are we going to get 1 on the right-hand side? If we replace x with 3, we have 3 divided by 3. 3 divided by 3 is 1, and the square root of 1 is equal to 1. So this satisfies the original equation, and so it's in our solution set. It's the only thing that we found in our solution set. All right, well, I hope that helps, and I will talk to you later. Bye.